Once again, welcome back. Today we are going to continue our discussion on zero divisors and integral domains. Of course, uh, this is a fresh, I think, fresh topic for today. Last lecture we have discussed the ring and its properties. And also we have seen when we say that a ring is commutative and what are the units. Okay, and so many examples we have also seen, including the examples of subrings and the sufficient condition for a set or for a subset to be a subring. Okay, so these things we have discussed in the past lectures. Of course, let us recall that any ring R, if it contains the multiplicative identity, okay, a ring R, which contains a non-zero element non-zero element E, such that AE equals to EA equals to A. Okay, for all A belongs to R, then we say that ring R with unity. Okay, we say that the ring R with unity. We say R as the ring with unity. The ring with unity. Okay, the ring with unity. And one more thing, a non-singular element or non-zero element which has inverse in it is said to be the unit of that ring. Okay, so these two are very important thing. And the third thing is the commutativity. Okay, first thing this one, and the second thing is unit. Okay, unit in R are those elements which have multiplicative inverse. And of course we know that this unity or identity and inverse, they always unique in their particular sense. Okay, and the third one is commutativity. They are going to play a big role hereafter. So commutativity or a commutative ring R is with property AB equals to BA for all AB belongs to R. So three things we have recalled. Fine. Many examples we have seen. Z, and we have seen this this example in case Zi or Zni. So whether this is this ring has unity or what depends on n. If n equals to, for example, 1, what about Z1i? This element has only 0. Okay, this element has 0 only zero element. Okay, fine. All right, because in Z1, this Zni, this contains the element of the form A plus IB. Okay, and AB belongs to Zn. In case Z1, there is only one element, that is 0. So both are going to be 0. So this is Z1I is going to be 0. That is a trivial ring. There is so many things. Sometimes some researcher says that this is a in this 0 in the zero ring, which contains the only zero element, the multiplicative identity and this additive identity coincides. Okay, because in a ring we must have two operations, addition and as well as multiplication. Fine. So for that, if suppose we have a ring, trivial ring, only zero element, so it has 0 times 0, this should be equals to 0. Okay, 0 times 0 should be equals to 0. And in general, 0 times a equals to 8 times 0. This is 0. Fine. This is fine. Like this. Okay. Sometimes they say that this 0, is nothing, this 0 and 1 coincides here. Okay. But thing is that we are not worried about that anyway, because this is not going to give us anything much. Fine. Let us move further. What did he say that z and n greater than or equals to 2? In this case, n greater than or equals to 2. In this case, we can write 1 as a 1 plus 0 times I. Okay. And this belongs to Zi, Zni, this element. Okay. And we can write this 1 as x into 1, as 1 into x, 1 into x. And this is true for all x belongs to, this is true for all x belongs to Zn, Zni. So this one this one works as work as the unity here. Okay. So Zni has unity. Another example we can, let us say this is number 1, this is number 2. I'll tell you quickly so many examples. Q times, if you take this one, R, okay. So what would be the identity here? Do you have any idea? This contains the element tuples type element, okay. So 1 is there. One identity, pick identity from Q and as well as from 0. So this belongs to Q times R, this Cartesian product, okay. And then you can multiply this 1 with any element of type A, B, where A belongs to Q and B belongs to the set of real numbers. And pointwise multiplication, so 1 time A, that is A, and 1 times B is equals to B. So this is again giving us the same element. Okay. So 1 is working as the unity. So unity is there. Unity is there. Number 3. Let us in a similar way we can try it out QZ and then Z cross Z Zi. Okay, and also we can try about a set of complex numbers. Even in general we can talk about n product of n c. Okay, and also we can talk about Zi cross product with C cross Q and C also. All uh, all are in unity, and you can find them. What are they? Fine. Some more interesting example you can know. You should know that if I'm writing R and Q times 0, so this is 0 ring with this. So can you tell any? Do you have any idea what is the unity in this? Is there? Hello. You need to find here. In Q, you have unity 1, and you will be getting a one element like this belongs to R. Fine. You can take other elements 1, 0, and then A, B, and then pointwise multiplication A, and then you will be getting 0 here. Okay. Sorry. Yeah, you will be getting 0 here. This B is nothing but 0 because this is Q times Q cross 0 is there. Okay. So you are getting the same element. So this is unity. This is unity of this. Okay. Similarly, you can also try, you can also see the examples like R cross 0. This has unity. All right. This also has unity. Z cross 0, this also has unity. Z cross Q cross 0, this also has unity. Okay. Z and then I and then singleton 0, this also has identity. Okay. Q cross R cross C and then 0 like this are rings with unity. Sometimes what happens once we see the 0 and we forget to see other things, and we say that 0 has no unity, multiplicative no have 0 has no unity, so there won't be any unity. Thing is that. So please, uh, that's why I told you sometimes people used to write like this, but thing is that this is not the case. Of course, this is a commutative. If we say this is a commutative ring, commutative ring, okay, commutative ring, and it has no unity. So we are not considering this kind of thing. Fine. Okay. So let us go further. Unless otherwise, so many author used to write that 0 and 1 should be distinct. That is, that element should not be equals to 0. Okay. And sometimes some author used to, some author don't write. Let us see the next concept is called zero-divisor. Zero-divisor. While dealing with numbers, we see that when product of two numbers is 0, then we assume that one of them is going to be 0. Thing is that if we have two numbers A and B, if their product is 0, so we say that either A is 0 or B equals to 0. But when we are in abstract algebra, this is not always true. There may be the situation when the two numbers are not 0, but their product is 0. Okay, so this concept is included here, and it is kept under the terms zero-divisor. Okay, so let R, let R plus dot be a ring, be commutative ring. Okay, be a commutative ring. Commutative ring. Be a commutative ring, and commutative ring. Yes. Let R be a commutative ring. Okay. A non-zero non-zero element A belongs to R is said to be zero-divisor if there exists a non-zero element B belongs to R such that A times B equals to 0. So if you can get two non-zero elements, whose product is 0, then we say that that element is zero divisor. Okay. In fact, if a is a non-zero element we are taking, and we are getting another non-zero element b, and we are saying that a times b equals to 0. So we say that a is zero divisor, and when a is zero divisor, b is also going to be zero divisor. Fine, just to change the role of a and b. So if a is zero divisor, then certainly b is also going to be a zero divisor. That is, both are zero divisor. Okay, both are zero divisors. In such examples, you can get in not only matrices but also in non-matrices. Other than, examples in other than matrices. So let us say example. Let us see Z12. Okay. In Z12, we can, the elements here 0, 1, 2, 3, like this. Okay. And this is up to 12 to 12. Okay, like this. So what we have? We have 3 times 4. 3, not 12, but this is 11. Okay, 11. 11. So we have 3 times 4, and this is when divided by this what is called 12. This gives us 0, but neither 3 is 0, not 4 is 0. Okay, so 3 and 4 are zero divisors. Okay, 3 and 4 are zero divisors. And of course, you can see that Zn, we have seen that Zn is a ring. Okay. Other examples in Z30 also, example number 1, and this is 2. In Z30 also, you can see, you can get 6 and 5 belongs to Z30. 6 times of 5 equals to 30. This is equals to 0, but neither 6 is 0 nor 5 is 0. Okay. So once we are taking, suppose we want to claim that 6 is a zero divisor. So we need to search another element like 5, with which when 6 is multiplied, it is giving 0, but okay, 6 is giving 0. So similarly, if you want to say that 5 is a zero divisor, so you need to search element like here in this case 6, so that their product is 0. Okay. Next example, if you see, let us say that let us take the ring Q and this product with R. It's also a commutative ring. So what about zero divisor? In this, you have element of the form 8 times 8 b tuples, and product, suppose if you are taking other elements CD, so you can write AC and BD. So component wise product is there. Fine. So you can take some non-zero elements. Suppose you let us take here 1 0. 1 0 belongs to QR. Q times R. Okay. Q times R. And you need to check whether it is a zero divisor or not. Thing is that zero divisor is a property of element. Zero divisor is a property of element, not of a set. Okay. So we are considering some particular element, and then we are claiming that that element, whether it is a zero divisor or not zero divisor. That's all. We are not telling that we are not telling about the ring, but we are talking about the element. Just like we have seen the concept of units in a ring. So that unit belongs to, or this is a property of a particular element. All right. Existence of unity, that is the identity, is a property of ring. But when we say that unit or we say that zero divisor, they are properties of element. Thing is that at least you should have idea of this. Okay, so can we have some element in a QR so that their product with this is 0? Can anyone tell me?
0,3.
0,3. Very good. What's your name?
Deepika Gupta.
Yeah, you can note down 1 point for this. 0,3, or you can take any element 0, some non-zero element. So you multiply these two. So what do you have? 1 times 1 into 0 and 0 into 3. Okay. So this is going to give us 0, 0, and this is a 0 of QR. All right. This is 0. This is 0 of QR. Q times R. Fine. This is 0. 0 of QR. But neither 1 comma this is 0. Okay. And nor this is 0 comma 3. What you have taken is 0. Fine. When we are I'm writing here 0 is meant to be, I'm talking about this 0, 0 comma 0. Okay. Like this. So this is how, so what is there? What we can say? There are zero divisors or not? There are zero divisors. Okay. So if you can have some property, now let us take this transformation. Sorry, let us take this element property of element, that is that particular element is a zero divisor to the set, that is to the ring. Okay. So in case if we have zero divisors in that ring, we say that that ring is with zero divisor. That's all. We like this we can associate. Okay. Now let us take another concept. We call it the integral domain. Integral domain. Integral domain. So here a commutative ring with unity, a commutative ring with unity is said to be an integral domain if it has no zero divisor. That is, if A, B belongs to R and A times B equals to 0, then either A equals to 0 or B equals to 0, like this. Okay. Did you understand?
Okay, sir.
So if the product of any two numbers in a ring is 0, then one of them has to be 0 at least. Okay. So then we say that commutative ring with the unity is an integral domain. This if you see that commutativity and this unity. Okay. Commutative was commutative is coming when we were talking about uh, the zero divisor. Okay, so it is okay, we have included here, but another thing we have included with unity. So when we talk about a zero divisor, we need to take a ring, a commutative ring. Unity is not needed, but here in a integral domain, we need to take a ring with commutativity as well as with unity also. Fine, it's clear. So here are two things are necessary to consider. Let us take some examples. Examples z plus n dot, the set of integer under addition and multiplication. Hereafter, I'll write integral domain as ID. Okay, ID for integral domain, or integral domain like this ID for integral domain. So I will use it throughout hereafter. ID for integral domain. So what is there in a Z plus? Is it integral domain or what? You take any two integers, a b equals to 0. So is there any situation when none of them is 0 and it becomes 0, their product becomes 0? Or else I can I ask, is there any zero divisor in Z?
No, sir.
Hmm? No, there is no zero divisor, because if a and b there are two integers, then this would imply that either a is 0 or b is 0. So this is integral domain. Next example, or similarly you can talk about q, and then real number, then complex number, then zi. Okay, what about z, zn,zni? This is integral domain q. Yes. Hello.
सर Z and I में तो zero divisors होंगे.
Yes. इसमें होंगे ना? Very good. Please note
Yes,
down
sir.
one point for this. Just we have talked about. I gave this example while illustrating the concept of zero divisors. हाँ? तो इसमें तो होंगे zero divisors. इसमें और इसमें नहीं होने वाले हैं ना? तो ये इंटीग्रल डोमेन नहीं है. Fine. Or भी examples, we can take other examples also. Let us take R with Q with product of the set of real numbers. Is it integral domain? Hello.
No, sir.
No, sir.
Yeah, big no. Just we have seen, we have discussed. You can take always a 1, 0, and then 0, 1, for example, in it, and then you can multiply them, and then you will be getting 0, and none of them is 0. Next, so this is not. Another, if we take the ring R, Q, and R cross, then R. What about this? Integral domain or what? No, you
No,
can
sir.
just yeah, you can write like this. How you can write 1, 0, 0, all right, and then you take another element here, 0, and then you can keep 1, 1 both places, multiply them element wise. Okay, so this is not again. Next example, let us see some interesting thing. What about this? Here, this set contains element of the form A and 0 of this form, where A belongs to the set of rational numbers. So, does this have zero divisor?
It doesn't have any zero divisor.
Sure.
सर है सर
Yes, sir.
अगर है तो क्या है बताइए ना आप. Zero divisor
सर
कौन से होंगे?
जीरो हो जाएगा सर.
You take an element from in it. Suppose A you are taking, and take another element here, B times 0, okay, and then the product of these two is going to be A B 0. Fine. So when this is equals to 0, if at all this is equals to 0, then this A B has to be what? 0. All right. So this implies that either A is 0 or B equals to 0. Either A is 0 or B is 0. All right. Okay. So next, so
तो
this is
इसका मतलब
integral
ये
domain.
इंटीग्रल डोमेन नहीं होगा ना?
Why? This q times 0, the zero ring, इसके पास है क्या जीरो डिवाइजर्स? नहीं है ना,
नहीं सर.
तब फिर कैसे होगा?
यस सर.
एक कम्यूटेटिव रिंग जिसके पास आइडेंटिटी है, अगर उसके पास जीरो डिवाइजर नहीं है ना, तो फिर वो इंटीग्रल डोमेन बन जाएगा. मतलब ना
Okay.
रखना इसके लिए वरदान है ना? समझ रहे हैं? इसके पास जीरो डिवाइजर नहीं है. तो ऐसे सिमिलरली और एग्जांपल्स बताएं आप क्विकली कि कौन कौन से हो सकते हैं, कौन से एग्जांपल और बना सकते हैं आप इस टाइप के. जेड है ना, और कॉम्प्लेक्स का, और बताइए रियल नंबर से, है ना, और बताइए
सर R क्रॉस R.
जेड आई, है ना, इससे भी हो सकता है. और आप क्या कर रहे हो, ऐसे कर रहे हो क्या,
R
आर
क्रॉस R.
क्रॉस आर ऐसे करके? हाँ,
No sir, only R क्रॉस R.
और क्रॉस आर, अच्छा, आर क्रॉस आर, अच्छा इंटरेस्टिंग. ये तो पता नहीं हमने हमें देखा क्या, नहीं देखा. हाँ ठीक है. तो आर क्रॉस आर क्या होगा, इंटीग्रल डोमेन होगा
Yes sir.
पक्का? इसके पास कोई जीरो डिवाइजर नहीं होना चाहिए. टेक एलिमेंट 1 0, अनदर एलिमेंट 0 1, इनका प्रोडक्ट निकालो.
0 0.
0 0.
और दोनों जीरो है क्या? नहीं, तो
No.
इसका मतलब ये भी जीरो डिवाइजर हुआ, ये भी जीरो डिवाइजर हुआ आर क्रॉस आर में, है ना? इसके पास तो मिल गए जीरो
Yes sir.
डिवाइजर्स, है ना? कितना इंटरेस्टिंग है. आर आर जो है इंटीग्रल डोमेन है, लेकिन आर क्रॉस आर नहीं बन पा रहा है ना?
नहीं है.
तो
Yes
इंटीग्रल
sir.
डोमेन होने के लिए ना, अब देखो ये सारे के सारे इंटीग्रल डोमेन होने जा रहे हैं, यहाँ पे जितने भी है ये सारे के सारे इंटीग्रल डोमेन होने जा रहे हैं हमारे, है ना? तो इस टाइप के जो एग्जांपल्स आ रहे हैं ना, जो हमें नहीं लग रहा था ना वो बन गया है पक्का. जो नहीं लग रहा था वो बना है. लेकिन जो अब देखो इसमें जैसे ही क्यू क्रॉस आर लिया, यहाँ ये भी नहीं बन पाया, ये भी नहीं बन पाया, है ना? तो यहाँ पे नहीं बन पा रहे हैं. चलिए ठीक, कोई दिक्कत अभी तक?
No sir.
ओके. कुछ और एग्जांपल्स हैं आपकी बुक से जिसको मैं कोट कर रहा हूँ. ये कहते हैं एग्जांपल नंबर 1 आपकी बुक का है, रिंग ऑफ इंटीजर्स इज एन इंटीग्रल डोमेन. सो दे आर टेलिंग इसके बारे में, ठीक है ना? इसको कह रहे हैं आईडी है, ठीक है. एग्जांपल नंबर 2 ये कह रहे हैं जेड आई, ठीक है, गॉसियन इंटीजर्स, ये भी इंटीग्रल डोमेन है, ठीक है. ये तो क्लियर है. जेड एक्स की बात कर रहे हैं, ये है द रिंग ऑफ पॉलिनोमियल्स. Polynomials with the integer coefficient. ये भी इंटीग्रल डोमेन होगा. फोर्थ, they are taking z square root of 2, and this is the collection of elements of the form a plus square root of 2b, where a b belongs to the set of integers, like this. This is also an integral domain. You can generalize this like where p is some prime. So a plus square root of 2 and square root of b, p, then b, such that a b belongs to the set of integers. Okay, ये भी इंटीग्रल डोमेन होगा. नेक्स्ट फिफ्थ, ZP इज, ये भी एक इंटीग्रल डोमेन होगा, इंटीग्रल डोमेन होगा, ठीक ना। यू नो दैट ZP also gives us some more information or more things that later on we will see that this becomes a what is called this, this will, we will prove this this is an integral domain actually. For this we need either we can do independent proof, or thing is that we need to based on some another what is called result, which says that every what is their no, yeah, I'll let you know how to prove this. Okay, let me give time. Okay, so this is the integral domain. Actually, there is a result which says that Zn
Zn
is
is
an
field if and
integral
only
domain
n is prime.
if and only if n is equal to p, that is a prime. Okay, yeah. So this result need to be proved. Anyway, if you want, let us prove. Okay. Okay, let us see the proof of this result. This okay. So let us assume let n equals to p. We are let p equals to t. P is a prime. Okay. So what we need to prove? We need to prove that Z is an integral domain. So to prove that ZP, in fact, is an integral domain, we need to show that ZP has no zero divisor. All right, ZP has no zero divisor. Okay. So now we claim that ZP has no zero divisor. No zero divisor. For this, let A and B, there are two elements. Okay, and let us assume that they belongs to P, and of course both okay, both are elements of ZP, and such that A times B equals to 0. Okay, A times B equals to 0. Fine. So if the product of these two is 0, it may, and of course because they are element of ZP, तो ऑपरेशन क्या होगा इसमें? मल्टीप्लिकेशन मॉडुलो P होगा. Fine. This is multiplication modulo P. Okay. So this means that what? This means that what?
AB is equal to P.
Yeah, AB equals to AB equals to some P times K, yeah, or K times P for some K belongs to Z. All right. Okay.
Yes, sir.
Okay. So it means what? It means that P divides, we can write P divides AB. P divides AB.
Yes, sir.
Now again, since P divides AB, so P divides AB, so
P
there may
divides
be two
A
possibilities.
and P divides P.
Either P divides A, if P divides A, then what? P is a multiple of, sorry, yeah, P divides A, this means that P is a multiple of, sorry, A is multiple of P. P divides A, so A is multiple of P, all right? And in this case, A has to be 0. समझ रहे हो आप? है ना? अगर P A को डिवाइड कर रहा है, ठीक है? अगर P A को डिवाइड कर रहा है, तो A को 0 हो जाना पड़ेगा फिर तो, अगर डिवाइड कर रहा हो तो, ठीक है ना? तो we are done then. in this case. Okay. The second case, if P does not divide A, then अब A भी जब A को डिवाइड नहीं कर रहा है, इसके प्रोडक्ट को डिवाइड कर रहा है, तो इसका मतलब क्या है कि
P
एक और
divides B.
ग्रेटेस्ट कॉमन डिवाइजर इन दोनों का क्या होगा? अगर A को डिवाइड कर रहा है, इन दोनों के प्रोडक्ट को डिवाइड कर रहा है, बट साइमल्टेनियसली P डजंट डिवाइड A, इसका मतलब ग्रेटेस्ट कॉमन डिवाइजर क्या होगा? इनका 1 होने वाला है. एंड P डिवाइड्स, देन इन दिस केस B हो जाएगा. ठीक है ना? एंड दिस इंप्लाइज दैट B इक्वल्स टू 0. ठीक है, क्योंकि B जो है किसका मल्टीपल हो जाएगा? K का मल्टीपल हो जाएगा. समझ रहे हो आप? है ना? हेलो.
Yes, sir.
जब हम लिखते हैं कि 2 डिवाइड्स 4, तो इसका मतलब क्या है कि 4 इक्वल्स टू सम K टाइम्स 2. यही तो होगा ना? समझ रहे हो? तो इसका मल्टीपल हो गया तो 0 हो जाएगा. ओके, ऑल राइट. So B has to be 0 in this case. So in the both cases, either P divides A or P doesn't divide A. Both cases we have one of them is 0. Either A is 0 or B is 0. Fine. So it means what? P has no 0. ZP has no 0 divisor. ZP has no 0 divisor. This implies that what? ZP is an integral domain. So converse part we need to take now again. Conversely, let I will prove it in contrapositive way. You know contrapositive way? Contrapositive way is
Not
P
Q implies not
Q. Contrapositive way of this one is not Q
implies not
implies
P.
not P. All right. So this you should note. So what we need to prove? We need to prove that n equals to P. Okay. So what we will prove? What we will assume that n is not equals to P, and then we prove that Z is not an integral domain. Okay. So let us assume that n is not equals to P. Then we claim what we claim. We claim that ZP is not an integral domain. Not in a is an integral domain. Okay. If n equals to 1, then Z1 is what? Z1 is 0. Z1 is 0, and there is no unity, so there is no. This is not an integral domain. Okay. Then Z1 equals to 0, which is not an integral domain. Okay. So here are done. So in the next case, this is the case first, case second. Let n is greater than 1 and n is not equals to P. Okay. So since n is an integer, so by fundamental theorem of arithmetic, which says that every natural number other than 1, okay, every natural number greater than 1, or I can say, can be written as product of prime numbers. Okay. Have you heard this theorem, this result? कि कोई भी नेचुरल नंबर जो एक से बड़ा है उसको हम प्राइम नंबर के प्रोडक्ट की फॉर्म में लिख सकते हैं. ठीक है ना? और यूनिकली लिखा जाएगा अप टू द पावर्स एंड देयर प्लेसेस. बहुत करेंगे तो प्लेसेस चेंज कर देंगे. कोई भी नेचुरल नंबर उठाइए, सपोज आप उठा रहे हैं 100 उठा रहे हैं. ठीक है ना? इसको आप क्या लिख सकते हैं? 2 to the power 2 एंड 5 to the power 2 लाइक दिस. ओके. कोई भी नेचुरल नंबर जो एक से बड़ा है, क्योंकि 1 तो प्राइम होता नहीं, तो इसको नहीं हम करेंगे, एक से बड़ा जो भी है. ठीक है? ऑल राइट. अब इसको बहुत कर सकते हैं तो आप ऐसे ही इसको चेंज कर सकते हैं. At most you can do like this, or you can write 2 times 5, 2 times 5, or you can write 5 times 2, 5 times 2, or you can write 5, 2, 2, 5, something. But thing is that there are number of ways to write, but the thing is that it will be the same. Okay, the primes will be same. Okay. I think we don't have much time. Let us finish it quickly. So we can write as a product of primes. So we have a p to the power alpha 1, p2 to the power alpha 2, and something pk to the power alpha k. Okay, alpha k. And let us write this is a times b, where a is, let us assume, p1 to the power alpha 1, and b is a p2 to the power alpha 2, p3 to the power alpha 3, and pn to the pk to the power alpha k, like this. Fine. So now n is greater than 1, we know. Okay, n is greater than 1. So, and of course, or I can write here. Now a is greater than 1 and less than n, because it's a product. Okay, these product of these two is equals to what? N. So this should be less than n. Okay, and also this a belongs to Zn, and again b is greater than 1 and less than n. This also belongs to Zn, and because a and b from Zn, so, and in Zn you have element starting from 0 until n minus 1. Fine. So like this. Okay, this belongs to okay. If in case if AB equals to 0, such that AB equals to 0, fine, and this is equals to n. Their product is n. Their product is n, and n is nothing but 0. Their product is what? Their product is n, and n is 0 of alpha Zn. Alpha k है इसको. Alpha k. This is alpha k. Alpha k. Fine. So AB times this is equals to 0 and is equals to n. So this implies what? AB equals to 0. But what we have considered, neither A is 0 nor B is 0. Okay, A is 0 nor B is 0. It means what? Z is not an integral domain. Okay, बिकॉज वन ए जो है एक से बड़ा है और बी भी इससे बड़ा है, ठीक है ना, इसलिए नहीं, और ऐसा इसलिए कर रहे हैं क्योंकि एन जो है हमने एक से बड़ा लिया ही है ना, एन एक से बड़ा लिया है, तो इन दोनों में से कोई तो जीरो होगा नहीं, ठीक है ना, बट दोनों का प्रोडक्ट क्या हो जा रहा है? जीरो हो जा रहा है। तो अगर हम वो ले रहे हैं तो इसका मतलब इसके पास जीरो डिवाइजर हो गया, जबकि हम वहां पे ऐसा मतलब अपोजिट एज्यूम करके चले हुए हैं, ठीक है ना। सो पुटिंग case 1 and 2 together, we conclude that Zn is an integral domain if and only if n is prime. So with this, let us conclude the discussion for today.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.